Part engineering is the aggregation of protein, promoter, RNA engineering, and the like. Sometimes a genetic device can only be concretized by addition of a non-natural biochemical component, and for such applications one must apply part engineering to generate a synthetic part. One trivial example of part engineering is the generation of constitutive promoters and ribosome binding site parts. We have discussed these types of parts and their use in previous chapters. In this example, a combinatorial library was used to generate a family of constitutive promoters that vary in strength over 3 orders of magnitude. However, today we are discussing the more advanced applications of part engineering where more complicated biochemical functions are required. Examples include enzymes whose substrate specificity is altered, RNAs that bind to small molecules, or transcription factors that site-selectively bind user-defined DNA sequences. There are very few examples in the literature of the integration of part engineering and device engineering. Though protein engineering is a large topic, it is rare to construct multi-gene devices and also include an engineered part. Part engineering is very different from device engineering. It deals with issues of three-dimensional structure and chemical details of intermolecular interactions rather than networks of molecules. As a result, the tools and approaches are quite different. Typically, combinatorial or directed evolution approaches using mutant libraries are required for this type of engineering. There are more directed approaches using computational tools and design strategies. Often these tools will be used in conjugation with library strategies. Most part engineering is for making purified protein products such as engineered therapeutic proteins or enzymes. There is also a large body of literature around engineering RNAs, a fair amount on promoters, and rare examples of other types of parts such as origins of replication. This type of engineering was popular before multi-gene device-style engineering, and thus there is an older and more extensive literature around protein and RNA engineering than there is around device engineering. The intersection of parts engineering and device engineering shows up in 2 areas. Device engineering is used to make genetic selections for screening through large combinatorial libraries of parts, and engineered parts can be combined with other parts to make new